October November 2024, October November 2024, पेपर 2 वेरिएंट 3। बेटा ये निकाल लो सारे। October November 2023, let's start this paper. This is what October November 2023, and this 2024, this is October November 2024, पेपर 2 वेरिएंट 3। ये निकाल लो बेटा, ये तो बहुत ही फ्रेश पेपर है। अच्छा मुझे अपनी ईमेल सेंड कर दो बेटा, अभी फौरन क्लास के बाद ही ईमेल सेंड कर दो, आई विल ऐड इट एसएप। चलो, नाउ let's see this. Define acceleration. You have to define acceleration. You have to define acceleration. What is acceleration? Acceleration is the rate of change of velocity. Acceleration is what? Acceleration is the rate of change of velocity. Let's write it down. Rate of, oh, what has happened here? Acceleration is what? Rate of change of velocity. Simple as that, nothing complicated here. A small aircraft is flying horizontally at a speed of 42 ms minus 1 at a height of 63 meter above the horizontal ground as shown in figure 1.1. Perfect. The aircraft drops a small parcel. The parcel is released from the aircraft at the instant shown in figure 1.1. Air resistance is negligible. Perfect. Air resistance is negligible. That means acceleration will be 9.81 ms minus 2. Perfect. On figure 1.1, draw a line to show the path of the parcel as it falls from the aircraft to the ground. Okay, we have to show the path of the parcel as it falls from the aircraft to the ground. Now, if you analyze बेटा क्या हो रहा है? If you analyze क्या हो रहा है? If you are throwing a parcel from here, देखो, a small aircraft is flying horizontally. This is an important word. At a speed of 42 ms minus 1. The aircraft drops a small parcel. So if you drop a small parcel here, currently this parcel will only have a horizontal velocity component, that is 42 ms minus 1. Currently, this parcel will only have a horizontal component, that is 42 ms minus 1. This is the initiate. This is the start of what? This is the start of half projectile motion. Initially, you will only have a horizontal velocity of 42 ms minus 1. Your vertical velocity will be 0. How will your path of parcel look like? Somewhat like this. Somewhat like this. This is your basic half projectile motion. Calculate the time taken from the instant of release to the instant the parcel reaches the ground. Perfect. We have to calculate the time taken for the parcel to reach the ground. How are we going to do this? If you analyze, we know that the initial vertical velocity is 0. Let's do the working in the vertical plane. Let's do the working in the vertical plane. If you analyze, initially you only have a horizontal velocity of 42 ms minus 1. And initially, this is your horizontal. Let me write it. Initially, you only have a horizontal velocity like this, and your vertical velocity initially is 0. Vertical velocity, initial vertical velocity would be a better word. Initial vertical velocity is 0. Perfect. So let's do the working in the vertical plane. Your u is 0. What is the vertical distance that you will fall? 63 meters. So S is 63 meters. Your acceleration is 9.81 ms minus 2. Can you calculate the time t? Can you do that? Yeah, you can apply this formula. S is equals to ut plus half a t square. Since u is 0, this entire term will become 0. S is what? 63 is equals to half into acceleration, that is 9.81 into time t ka square. Can you calculate time t? 63 into 2 divided by 9.81 taken under root. What does your time comes out to be? What does your time comes out to be? 63 into 2 divided by 9.81. What does your time comes out to be? Yes, divided by 9.81 taken under root. What does your time comes out to be? Your time comes out to be 3.58 seconds is your time to reach the ground. Simple as that. आगे बढ़ते हैं बेटा. Once I finish the entire question, I will take your questions. और बीच में अगर कोई सवाल है, you can obviously ask it as well. Calculate the vertical component of the velocity of the parcel immediately before it reaches the ground. Okay. So you have to calculate the vertical component at this point. You have to calculate the vertical component of the velocity at this point. Let's again do the working in the vertical plane. Let's again do the working in the vertical plane. Your initial vertical velocity was what, beta? Zero. Why? Because you are launching it horizontally. Remember this word. Whenever you see a launch that is horizontally, that means your vertical velocity becomes zero. Your acceleration due to gravity is 9.81 ms minus 2, and you have just calculated the time. Time was what? 3.58 seconds. Time was 3.58 seconds. Can you calculate the final velocity? Can you calculate v? Yeah, v is equals to u plus at. Initial velocity is what? 0. Acceleration is 9.81. What is the time? 3.58 seconds. What does your answer come out to be? 9.81. 35.2. 35.2 ms minus 1 is your answer. Simple as that. Nothing complicated. Let's further move ahead. Determine the speed at which the parcel reaches the ground. Now, please analyze whenever only speed is written. Whenever only speed is written or total speed is written, the examiner is asking you to calculate the resultant speed. The examiner is asking you to calculate the resultant speed. As the parcel hits the ground, as the parcel hits the ground, can you realize the vertical velocity will be what? The vertical velocity will be 35.2 ms minus 1. And the horizontal velocity will be what? The horizontal velocity will remain the same at 42 ms minus 1. Why? Because the horizontal component of the velocity in projectile motion remains same throughout. The horizontal component of velocity in projectile motion remains same throughout. Can you calculate the resultant velocity or the resultant speed, or you can say the total speed in this scenario? Can you calculate the total speed in this scenario? Yeah, very, very easy to calculate. How will you do that? You will, you can obviously apply the Pythagoras theorem directly, but let me build up some concepts here. Can you see that this is the tail of the vector? This is the tail of the vector. Currently, both the tails are connected together. Hence, the head to tail rule is not being applied. You will shift the vector towards the downside. Now, the head to tail rule is being applied. Simple. How can you make the resultant vector like this? This is your resultant vector. This is your 90 degrees. Can you calculate the resultant vector? Yeah. Resultant vector is equals to what? Under root 42 square plus 35.2 square. What does the resultant velocity comes out to be? 55 ms minus 1 is your answer. Simple as that. Any complications here? Any questions that you want to ask in this entire sawal? State the principle of conservation of momentum. What is principle of conservation of momentum? The total momentum of a system is constant given that there are no external forces acting on the system. You can write here the total momentum of a system remains constant or slash conserved given that no external force acts on the system. Simple as that. Let's further move ahead. A ball X has a mass of 240 grams. Perfect. Ball X has a mass of 240 grams and moves in a straight line on a horizontal frictionless surface with an initial speed of 16 ms minus 1. Perfect. The ball collides with a stationary ball Y, which has a mass of 480 grams. After the collision, ball X is stationary as shown in figure 2.1. Perfect. Show that the speed v of the ball after the collision is 8 ms minus 1. Which thing will we apply here? We will apply that momentum before collision or total momentum before collision is equals to total momentum after collision. What is the total momentum before collision? Now, even though this is not required here and I don't think this will affect the answer, but whenever you have velocity or vector quantities in the equation, you will consider marking the axes. What are axes? Axes are just a guideline to tell the examiner that the right side vectors are positive, the left side vectors will be negative. So momentum before the collision has what? Momentum before the collision will be what? 240 grams into 16. Convert 240 grams into kg 0.24 into the 16 ki velocity that is acting towards the right. Plus this velocity, this ball y has a velocity of 0. So 0.48 into 0. If you are a genius, you know this will get cancelled out or get zeroed out. Okay, momentum after collision, you have a mass of 240 grams, 0.24 into 0 plus 0.48 into V. This 0, perfect. 0.24 into 16 divided by 0.48 is your velocity. This is 1, this is 2, this is 1, this is 8. Your velocity comes out to be 8 ms minus 1. Simple as that. Calculate the change in kinetic energy of the balls due to the collision. We have to calculate the total change in kinetic energy. So, what is the kinetic energy before collision? What is the kinetic energy before collision? 1 upon 2 into the mass. What is the mass? 240 grams. That is 0.24 into the velocity of square. That is 16 square. That is 16 square. What is the kinetic energy before collision? 0.24 into 0.5. This comes out to be 30.72. The kinetic energy before collision is what? 30.72 joules. Can you calculate the kinetic energy after collision? Yes, 1 upon 2 into what is the mass? Mass is 0.48. After collision, there will be no kinetic energy of ball X. The kinetic energy of ball X after collision will be 0 because the velocity of ball X after collision is 0. Simple. And same applies here. The kinetic energy of ball Y before collision will be 0. Why? Because before collision, the velocity of ball Y is 0. Simple. Can you calculate the kinetic energy of ball Y after collision? Yes, 0.48 into the velocity 8 square. This comes out to be 8 square into 0.48 into 0.5. This comes out to be 15.26 or 15.36 joules. Can you calculate the change in kinetic energy? Yes, 30.72 minus 15.36. What is your change in kinetic energy? Yeah. What does your change in kinetic energy comes out to be? 30.72 minus answer 15.4 joules till three significant figures or 15 joules till two significant figures. Let's further move ahead. The collision in B lasts for a total time of 2 milliseconds. Perfect. Assume that the contact force between the balls during this collision is constant. Determine the magnitude and direction of the force exerted on ball X by ball Y during the collision. Perfect. So you have to calculate the force. How are you going to calculate the force? Very, very, very easy. To calculate the force, what you can do, first of all, let's see which force is required. You have to calculate the magnitude and direction of force exerted on ball X by ball Y. Perfect. So basically, you want to know the direction of force that ball Y exerts on ball X. Basically, this force. I don't know the direction, so I am currently marking it like this. I don't know the direction, so I am currently marking it like this. I am assuming that the force will be in this direction. Perfect. Now, how can you calculate this force? You can easily calculate this force by considering this formula. Force is equals to change in momentum over change in time. Perfect. Now, how will you calculate this change in momentum? You can either consider the change in momentum of ball X, or you can consider the change in momentum of ball Y. Now, how will you calculate the change in momentum? Change in momentum here is equals to the change in momentum of X. Okay. How can you calculate this change in momentum of X? Very, very easy. Can you see the final momentum? The final momentum of X will be what? 0. The final momentum of X will be what? Final momentum minus initial momentum. The final momentum of X will be 0. Why? Because the final velocity of X is 0. Simple. What is the initial velocity? 16. Can you calculate the initial momentum? Yeah. 0.24 into 16. This comes out to be what? 0.24 into 16. And this gives you an answer of negative 3.84. This is your change in momentum for X. Do you guys realize that the change in momentum is equals to the change in momentum of X, and this is how you will calculate the change in momentum? Perfect. Now, can you calculate the force here? Force is equals to negative 3.84 divided by the time. That was what? The time was 2 milliseconds. So let's divide it by 2 milliseconds. 2 into 10 is the power of minus 3. Can you guys calculate this answer? 2 into 10 is the power of minus 3. This comes out to be 1920 newtons, and a negative sign with it. And a negative sign with it. Now, what does this negative sign tells us? बेटा नेगेटिव साइन इज ऑफ ग्रेट इंपॉर्टेंस हियर. देखो अब तुम्हें पता चलेगा. नाउ यू विल गेट टू नो व्हाई दीज एक्सेस मार्किंग वाज इंपॉर्टेंट. Force is a vector quantity. The negative sign tells me that the force is acting towards the left. So now you have the magnitude as well, you have the direction as well. Let's take this and place it where we were asked about it. Here. The negative sign tells us the direction, that is to the left. To the left. What is the magnitude? 1920 Newton. Simple as that. अच्छा अब देखो. Compare the magnitude and direction of the force exerted on ball Y by X during the collision with the answer in C1. No further calculations are required. Now I need you to focus on the board for the next 5 minutes. Now we have to calculate this force that ball X will exert on ball Y. Let's label this as force Y, and let's label this as force X. Now, please, please, please remember, whenever a collision happens, the force that one object exerts on the other object is equal and opposite to what the other objects exerts on the first object. थोड़ा सा complicated मैंने बात कह दी है. But whenever a collision happens, Newton's third law apply. And the force that one object applies is equal and object to the force that other object applies. Beta, whenever a collision happens, the force that one object or one ball will apply will be equal and opposite to the force that the other ball applies. Fx will be negative of Fy. Always remember this. Whenever a collision happens, Newton's third law gets applied, and we will have equal and opposite forces. So what will you write here? What will you write here? The the magnitude, the magnitude of force exerted on ball y is same, but the direction, the direction of force is opposite. And where is the direction of force? Where is the direction of force? Towards the right. Simple as that. Are there any complications in this entire question? Yes, बेटा सवाल पूछो कोई सवाल है तो no questions let's further move ahead. Clear है चलो. State the principle of moments. What does the principle of moment states? Sum of clockwise moments equals to the sum of anti-clockwise moments for an object in equilibrium. So you will write here for an object, for an object to be in equilibrium, to be in equilibrium, the sum of clockwise moments is equal to the sum of anti-clockwise moments. Simple as that, nothing complicated. Now let's see part B. A rigid uniform beam rests on a pivot at its center as shown in figure 3.1. Perfect. So what does the meaning of uniform? What is the meaning of uniform? Uniform means that weight of beam acts in the middle. Uniform means weight of the beam acts in the middle. Simple. This is a load that has a weight of 2.6 Newton. This is a pivot. Okay, let's read the question out. A load of weight 2.6 Newton is suspended from the beam at a distance of x from the pivot. Yeah, this is a load of 2.6 Newton. This is at a distance of x. Perfect. A wooden cylinder of weight 4 Newton is suspended from the beam at a distance of 0.4 meter from the pivot on the opposite side of the pivot to the load. Yeah, can you see this? This wooden cylinder is suspended at a distance of what? 0.4 meters. This wooden cylinder with a weight of 4 Newton is suspended at a distance of 0.4 meter. The cylinder rests in a container of water. The lower part of the cylinder is immersed in a water to depth of h. Perfect. So the cylinder is immersed in water till a depth of h. Perfect. Initially h is equals to 0.1 meters and x is equals to 0.4 meters. Perfect. So initially x is equals to 0.4 meters and h is equals to 0.1 meter. The system is in equilibrium. The system is in equilibrium. Now, if the system is in equilibrium, what does this mean? This means that the sum of clockwise moments will be equal to the sum of anti-clockwise moments. Use the principle of moments to show that the upthrust exerted by the water on the cylinder is this. We have to show that the upthrust exerted by the water on the cylinder is this. Perfect. Now, just for a moment, sit back and relax and see what are the forces that are acting in this scenario. First of all, we will have a weight here, this weight of the load. Perfect. This is acting downward. This weight is 2.6 newtons. This weight will turn the rod in which direction? This weight will turn the rod in which direction? It will turn the rod in anti-clockwise direction. Perfect. Now let's examine the cylinder. Let's examine this cylinder. This cylinder has a weight acting downward. This cylinder has a weight acting downward. That is a 4 Newton. But if you realize, there might be an upthrust force acting as well. There might be an upthrust acting as well. So what is the resultant force for the cylinder? What is the resultant force for the cylinder? Weight, that is 4 Newton minus upthrust. This is the resultant force for the cylinder. Weight is acting downward, weight is 4 Newton, upthrust is acting upward. The subtraction of both will give you the resultant force. Okay. So here, let's draw it here. So you can say that instead of these two forces, you can say that only a single resultant force is acting, that is Fr. And this Fr will be pointing downwards. This Fr will be pointing downwards. In which direction will this resultant force turn the beam? In which direction will the resultant force turn the beam? Yes, but a resultant force will turn the beam in which direction? If you have a resultant force, weight minus upthrust, in which direction will the resultant force turn the beam? The resultant force will turn the beam in clockwise direction. Now, we know that anti-clockwise moments are equals to clockwise moments. What is the anti-clockwise moment? 2.6 multiplied by the distance, that is x. 2.6 multiplied by the distance, that is x. What will be the clockwise moment? Weight minus upthrust multiplied by the distance, that is 0.4. Weight minus upthrust multiplied by the distance, that is 0.4. Now we know that x is equals to what? 0.4. X is equals to 0.4. How will we calculate this x? Very, very easy. 2.6 into 0.4 is equals to the weight, that is 4 minus 0.4. Sorry, my bad. The weight is 4. Up thrust we don't know, multiplied by 0.4. Perfect. So can you see this and this get cancelled out? 2.6 is equals to 4 minus up thrust. Up thrust is equals to 4 minus 2.6. Up thrust comes out to be 1.4 Newton. Is this clear? Always remember that if two forces are acting on the same object, you will calculate the moment using the resultant force. Is this part clear? This was an interesting question. Perfect. Chalo, let's move ahead. If you have any ambiguities here, beta, you can ask. If you have literally any ambiguities here, you can ask. Okay. No ambiguities here. Chalo, let's move ahead. Let's further continue with our question. Now, the density of water is this. Perfect. So the density of water is given. Calculate the cross-sectional area of the cylinder. Very, very easy. You are given the density of water. Now you have to calculate the cross-sectional area of the cylinder. Just sit back and realize this thing. Just sit back and realize this thing. Up thrust is equals to what? Up thrust is equals to density of the fluid, gravitational field strength into the volume of the object that is immersed in the fluid. When we calculate upthrust, we only take the volume of the object that is immersed inside the fluid. Perfect. So we will take this blue highlighted volume. Now, are you given the upthrust? Yes, 1.4. Are you given the density of the fluid? Yes, 1 into 10 is the power of 3. Are you given G? Yes, that is 9.81. What will you do with the volume immersed? You will say volume immersed is equals to the cross sectional area into the height h. Now, if you look closely and if you are paying attention, the height h was given 0.1 meter. So instead of h, what will we substitute? Instead of h, we will say it is 0.1. Can I calculate the area? Yes, 1.4 divided by 10 is the power of 3 into 9.81 into 0.1. What does your area comes out to be? Your area comes out to be 1.4 into 10 raised to the power of minus 3 meter square. Nothing complicated. More water is gradually added to the container in B. Perfect. So that the depth in H is gradually increased. Perfect. The length x is continuously adjusted so that the system remains in equilibrium. Better realize क्या हो रहा है. Just realize what is happening. Just realize what is happening. If you can visualize in physics what is happening, everything gets easy. So the depth h keeps on increasing. Okay. If this depth h keeps on increasing, what will happen? If you analyze what was the formula of upthrust, upthrust is equals to the density of fluid, gravitational field distance into the volume of the object. If this h keeps on increasing, your upthrust will keep on increasing. Let me write the formula of upthrust here again as well. Upthrust is equals to the density of fluid into g into volume of the object. Upthrust is equals to density of fluid g into area into height. As height keeps on increasing, the upthrust will keep on increasing. Perfect. If the upthrust keeps on increasing, if the upthrust keeps on increasing, what will happen to the resultant force? The resultant force will decrease because a larger amount is now getting subtracted from the weight. Resultant force decreases. If your resultant force decreases, that is, this entire value, weight minus upthrust, decreases. If this entire value decreases, what will happen? Clockwise moments decrease. As clockwise moments decrease, better now visualize it, you are closer to solving this question. As clockwise moments decrease and you want to keep the system in equilibrium, what will you do? As clockwise moments decrease, you will make sure anti-clockwise moments also decrease. And if you want the anti-clockwise moments to decrease, your value of x should decrease. Simple as that. See how logically we have understood this. Sketch the variation of x with h. Use the space below for any working. So as you can realize, as h is increasing, x is decreasing. As h is increasing, x is decreasing. We already have 1 point. We already have 1 point. When x was 0 0.4, h was 0 0.1. We have this point. Perfect. Now, for a line to be drawn, we need at least 2 points. For a line to be drawn, we need at least 2 points. We need at least 2 points. So, what can we do? Let's say we take another point at your choice. Let's say 0.2. Let's take another point at h is equals to 0.2. Let's say h is 0.2. Perfect. Let's say h is 0.2. Let's see what the upthrust will be now. बेटा अगर h 0.2 हो गया, what will be the upthrust now? Very very easy to calculate. Let's do it here. If h, you can take any random point. I am taking this point. If h is 0.2, your upthrust will be equal to what? Upthrust is equals to 1000 into g, that is 9.81, into area. What was the area coming out to be? Area was coming out to be 1.4 into 10 raised to the power of minus 3. 1.4 into 10 raised to the power of minus 3 multiplied by 0.2. Can anyone calculate the upthrust here? Can any genius in the chat calculate the upthrust here? Into 1.4 into 10 raised to the power of minus 3 into zero point 0.2. This gives you a value of upthrust comes out to be 2.75 Newton. If the upthrust is 2.75 Newton, what will this resultant force become? What will this resultant force become? Let's calculate that. If upthrust is 2.75 Newton, let's say you have an h is equals to 0.2 meters. If upthrust is 0. If upthrust is 2.75 Newton, what will the clockwise moments become? Weight, that is 4, that minus 2.75 multiplied by 0.4. What will be your anti-clockwise moment? In your anti-clockwise moment, the force will still remain 2.6. X is unknown. What will x come out to be? 4 minus 2.7. 5 into 0.4 divided by 2.6. X comes out to be 0.193. This is your x when h is 0.2. Do you guys get it? Let's put this calculation on the downside. Let's put this calculation where it belongs in the second part. Up till then, if you guys have any questions, beta, you can ask. अगर कोई question है, you can ask. This is how you find the second point. This is how you find the second point. So let's keep it here and let's bring this working here as well. Chalo ji. Yeah, any questions? Yes, geniuses. Oh, what has happened here? One second. Yeah, I don't know why this is happening. Okay, chalo. One second. Yeah, let's keep it here. Oh, this is again getting messed up. Let's leave it. So at h is equals to 0.2, your x is 0.19. Where will 0.19 lie? 0.19 will be somewhere here, or you can say 0.193. So you have this point at h is equals to 0.2, your x is equals to 0.193. So this is 0.18 and your 0.19 will be somewhere here. Let's draw a graph through these 2 points like this. Make sure that you draw it as accurately as possible. Mhm. Yeah, is this clear to everyone? Any ambiguities, students? Anything that you fail to understand here, you can ask. Roughly, it will pass from here. Yeah. Any ambiguities here? Perfect. आगे बढ़ते हैं. चलो, let's move on. Let's move on to question number 4. Define stress. What is stress? What is stress? Stress is force per unit cross sectional area. Easy peasy marks. Force per unit cross sectional area. What is strain? Strain is equals to what? Extension per unit and stretch length. Extension per unit unstretched length. Simple. Let's further move ahead. Two wires X and Y. Okay, so we have two wires X and Y with unstretched lengths, perfect, of 0.84 meters are suspended from fixed points, perfect, that are at the same horizontal level, perfect. The lower end of the wire are attached to a beam of negligible mass, perfect. The beam is horizontal and is in equilibrium, perfect, as shown in figure 4.1. Wire X has a metal that has a Young's modulus of 1.9 into 10 raised to the power of 9, perfect. Wire Y is made from a different metal. That means it will have a different Young modulus. This means that it will have a different Young's modulus. Simple. Simple as that. Let's further move ahead. A load of 18 Newton is suspended from the beam at a point that is adjacent from the two wires. This load causes both the wires to extend by 0.7 millimeter. So the extension of this wire is also 0.7 millimeter and the extension of this wire is also 0.7 millimeter. Can you see both of these wires are connected in parallel? Hence the force will get divided. Wire X will receive a force of 9 Newton. Wire Y will receive a force of 9 Newton. Simple. Let's further see what is asked. Determine the cross sectional area of wire X. You have to determine the cross sectional area of wire X. Yeah. So we have to determine the cross sectional area of wire X. Now visualize something. Slowly, slowly start to visualize things. If you analyze wire X, wire X, Do you have the length of wire X? Yes, 0.84. Where do we have it here? Do you have the extension of wire X? Yes, 0.47 millimeter. Do you have the force of wire X? 9 Newton. Perfect. Do you have the Young's modulus of wire X? Yes, 1.9 into 10 is the power of 9. Any formulas that we can apply here for wire X? Yeah, any formulas that we can apply here for wire X? Do you remember the Young's modulus ka formula? Do you remember the Young's modulus ka formula? E is equals to FL over AE. Perfect. Can you isolate the area? Yeah. Area is equals to FL over E. E. F is what? 9. Length is 0.84 meters. Young's modulus is 1.9 into 10 raised to the power of 9. Extension is what? 0.47 into 10 raised to the power of minus 3. Can you guys calculate the area? Yes, can you guys calculate the area? What does the area comes out to be? What does the area comes out to be? Any geniuses that we have here? 8.5 into 10 raised to the power of minus 6. 8.5 into 10 raised to the power of minus 6 is your area. Now, wire Y has a greater diameter than X. Perfect. Explain without calculation whether the Young's modulus of the metal from which wire Y is made is less than, the same, or greater than 1.9 into 10 raised to the power of 9. Okay, so realize what the examiner is asking you to calculate. The examiner is asking you to calculate the relationship between area and the Young's modulus. So let's write down the formula again. Let's write down the formula again. Young's modulus is equals to FL over AE. Perfect. If you see, the force on both wires is constant. The force on both wires is constant, that is 9 newtons. Both wires have the same unstretched length, that is 0.84 meters. And both wires have the same extension, that is 0.47 millimeter. So all these three variables are constant. What can you say here? Young's modulus is inversely proportional to area. Young's modulus is inversely proportional to area. Perfect. Now, if you are saying, if you are saying wire Y has a greater diameter than what? Wire Y has a greater diameter than X. So wire Y will have a greater area. If wire Y has a greater area, what do you see? For a greater area, the Young's modulus will be lesser. You can write it like this. Wire Y has a greater area than wire X. Hence, the Young's modulus of Y will be less than the Young's modulus of X. Let's write down the answer. You will say, since, since force, length, and extension are constant, Young's modulus, Young's modulus, and area are inversely proportional. Young's modulus and area are inversely proportional. As Y has a greater area, greater area than X, the Young's modulus, the Young's modulus of Y will be less than 1.9 into 10 is the power of 9 Pascal. Simple. Let's further move ahead. A stationary wave is formed on the spring that has a length of 0.48 meters. Figure 5.1 shows the string at one instant in time. Perfect. The speed of the string is this. Perfect. On figure 5.1, draw a cross at one position, that is node, and another cross at one position, which is an antinode. Label the node N and label the antinode A. So where is the node? Here. Let's label it N. Where is the antinode? Here. Let's label it A. Simple. Show that the wavelength produced is this. Explain your reasoning. You have to calculate the wavelength. Can you realize this is a node? And this is also a node. This is also a node. This is also a node. The distance from node to node is half lambda. The distance from node to node is again half lambda. And the distance from node to node is again half lambda. So what can you observe? What can you observe? Half lambda plus half lambda plus half lambda is equals to 0.48 meters. 3 over 2 lambda is equals to 0.48 meters. Lambda is equals to what? 0.48 into 2 divided by 3. Lambda comes out to be what? This becomes 1, this becomes 1 6. Lambda comes out to be 0.32 meters. Calculate the frequency. How will you calculate the frequency? V is equals to F lambda. Velocity is what? 1400. Perfect. Frequency is unknown. Lambda is 0.32. Can we calculate the frequency? Yeah. Frequency comes out to be 1400 divided by 0.32. What will your answer come out to be? 1400 divided by 0.32. The answer comes out to be 4380 hertz. Simple as that. Nothing complicated here. Literally the easiest question on the block. Let's further move ahead. A source of sound waves of frequency this. So this is the frequency of sound. Fs is on a rotating platform. The speed of the source is this. Okay, this is the speed of the source. Sound is detected by an observer that is large distance away from the rotating platform as shown in figure 5.2. Okay. The speed of sound is this. Perfect. This is the speed of sound. Perfect. Calculate the maximum frequency of the sound detected by the observer. How can we calculate that? The maximum frequency will be observed when the sound source is moving towards the observer. Beta, when this sound source is moving towards the observer, you will observe the maximum frequency. And the formula for sound observed or frequency observed when an object is moving towards you is what? Frequency of sound multiplied by the speed of sound divided by the speed of sound minus the speed of the object. What is the frequency of sound? 480 hertz. The speed of sound frequency of sound is 480 hertz. What is the speed of sound? 320 minus 320 divided by 320 minus 39. What comes out to be your answer? Any geniuses in the chat? The maximum frequency comes out to be what? 390 hertz. Simple as that. The maximum frequency comes out to be 390 hertz. Let's further move ahead. At time t is equals to 0, the observer detects the sound emitted by the source when it is in the position shown in figure 5.2. Perfect. So in this position shown, the observer is detecting the sound. Now, if you realize, beta, if you realize here, what will be the frequency detected in this position shown? I think यही लिखा हुआ. At time t is equals to 0, the observer detects the sound emitted by the source when it was in the position shown in figure 5.2. Yeah. So initially at time t is equals to 0, the observer hears the frequency when the sound source is in this position. Now I will draw three positions of this source. Pay attention, I need your undivided attention. Currently, beta, the examiner is saying sound source is in this position. It is moving upwards like this. Can you realize this source is neither moving away or towards this point? Let's say this is position A. At position A, the sound source is neither moving away or towards the observer. Let's analyze option B. This is, let's say, position B. In position B, the sound is what? Moving away. In position B, the sound is moving away. And let's analyze position C. In position C, the sound is moving towards the observer. Are all three positions clear to you? Are these positions clear? Okay, at position A, the sound source is neither moving away or towards the observer. At position B, it is moving away. At position C, it is moving towards. Perfect. Now, what do we have to draw? Let's see what do we have to draw. On figure 5.3, sketch the variation with time t of the frequency of sound detected by the observer for one complete rotation of the platform. Calculations are not required. Okay, so you have to show how the frequency varies between the one complete rotation. Hmm. How will we do that? We have to show how the frequency varies as the one cycle gets completed. Hmm. Yes, any idea? Yes, beta, any idea? If you realize, you will start from the middle position, or you will start from, you can say, the main position. You will start from here. This is your position A. Perfect. Now, what is the second point that you have? Beta, please analyze that you are moving in this direction. What is the second point that you have? You are moving away. If you move away, your frequency observed decreases. Here, your frequency observed will decrease. So, what will you have next? You will have a little decrease in frequency. Let's say this is point B. Then your frequency will again increase to the mean position. Why do I do this? Why do I do this? Because can you realize again? Let's say this is point D. Let's say this is point D. At this point, you are neither moving away or towards the observer. So let's mark the points. Let's say this is A, let's say this is D, let's say this is B. What is the last point? The last point is C. At point C, you will have a maximum frequency again. Why? Because at point C, you are moving towards the object. Is this question crystal clear to all of you? And if I were you, I wouldn't have done this. Instead, I would have marked a mean position here. यहाँ पे मैं एक मीन पोजीशन एग्जामिनर को बना के दिखा देता कि भाई दिस इज द मीन पोजीशन. Simple. And this is your frequency F naught. Oh, sorry. This is the frequency of sound Fs. And Fs was what? The original frequency of sound was 780. So you can write it here. 780 hertz. Nothing complicated. Perfect. Let's wait then move ahead. Define resistance. What is resistance? Very, very, very easy to define. Potential difference per unit current. Potential difference per unit current. Per unit current. Simple. A cylindrical metal wire of length 2.4 meters, cross sectional area this, has a resistance of this. The current in the wire is this. Determine the resistivity of the metal from which the wire is made. The resistance is equals to resistivity length divided by area. What is resistance? Yeah, resistance is 0.33 multiplied by the area, that is 8 into 10 raised to the power of minus 6, divided by the length. What is length? 2.4. What does your resistivity come out to be? Yes, beta, resistivity comes out to be what? 1.1 into 10 raised to the power of what? 1.1 into 10 raised to the power of minus 6 is your answer. 1.1 into 10 raised to the power of minus 6 is your answer. Calculate the charge that passes through the wire in a time of 5 minutes. Basic question. Charge Q is equals to IT. What is the current? Current is 4.7. Perfect. What is the time? 5 minutes. So 5 into 60 to convert it into seconds. What will be the charge that passes through the wire? 1400 coulombs. Simple. The free electrons in the wire have an average drift speed of this. Determine the number density of the charge carriers in the metal. We have to determine the number density of charge carriers in the metal. Do you remember the formula of drift velocity or drift speed? Yeah. V is equals to current divided by NAQ. Now, now, can you realize? Can you realize here we have a very big problem? Here we have a very, very big problem. What is that problem? Here we have the speed in what? Millimeter second minus 1. So 0.16 millimeter second minus 1. To convert it into meter second minus 1, what will we do? We will say 0.16 into 10 raised to the power of minus 3 meters second minus 1. We have converted this milli into 10 raised to the power of minus 3. Perfect. So now you have this velocity, that is 0.16 10 raised to the power of minus 3. Current is 4.7. You want to calculate the number density. Area is what? Area was 8 into 10 raised to the power of 6. Perfect. 8 into 10 raised to the power of minus 6. What is the charge of an electron? 1.6 into 10 raised to the power of minus 19. Simple. Can you calculate n? Can you calculate n? Yeah, very easy to calculate. N comes out to be what? N is equals to 4.7 divided by 0.16 into 10 raised to the power of minus 3 into 8 into 10 raised to the power of minus 6 into 1.6 into 10 raised to the power of minus 19. Can you guys calculate n? Yes or no? What does n comes out to be? 2.3 into 10 raised to the power of 28. 2.3 into 10 raised to the power of 28. Simple. Let's further move ahead. The wire in B may be considered to be a fixed resistor. Perfect. It is connected in series with a thermistor to a battery that has negligible internal resistance. Use circuit symbols to complete figure 6.1 to show the circuit diagram of this arrangement. So the wire behaves as a fixed resistor. So what can you draw? You can draw a fixed resistor and a thermistor like this. This is your fixed resistor and this is your thermistor. Simple as that. Explain without calculation how the power dissipated in the wire changes as the temperature of the thermistor is increased. So as the temperature of the thermistor increases, what will happen? Resistance decreases. As the resistance decreases, the total resistance of the circuit decreases. As the total resistance decreases, the current increases. And as the current increases, according to P is equals to IV formula, as current increases, power will increase. Simple. So you can write it here. As temperature increases, resistance of thermistor decreases. As temperature increases, increases, resistance of thermistor decreases. Resistance of thermistor decreases. Simple. And as resistance of thermistor decreases, what will happen? As resistance of thermistor decreases, what will happen? The total, hence, the total resistance decreases, current increases, and the power dissipated increases. And the power dissipated increases. Simple as that, nothing complicated. Let's further move ahead. Now let's see this. Complete table 7.1 to show the charges in terms of the elementary charge E on each of the following flavor and anti-cork shown. What is the charge of up cork? What is the charge of up cork? Yeah. What is the charge of up cork? Plus 2 over 3e. What is the charge of anti up cork? Minus 2 over 3e. What is the charge of down cork? The charge of down cork is minus 1 over 3e. What is the charge of anti down cork? Plus 1 over 3e. What is the charge of strange cork? Minus 1 over 3e. What is the charge of anti strange cork? Plus 1 over 3e. State the name of the class of group of fundamental particles to which barons and mesons belong. Beta, barons and mesons belong to which group? They belong to hadrons. Barons and mesons belong to which group? Hadrons. Compare barons and meson in terms of their constituent particles. Barons are made of three quarks, whereas mesons are made of two quarks, one quark and one antiquark. Always remember, in a meson you will have one quark and one antiquark. Simple as that. Describe beta positive decay in terms of fundamental particles involved. Describe beta positive decay in terms of fundamental particle involved. What happens in beta positive decay, beta? What happens in beta positive decay? A proton changes into a neutron. In a beta positive decay, a proton changes into a neutron. So you will say an up quark, an up quark changes into a down quark. And what else do we know? There are two more fundamental particles that are released. Positron and neutrino is emitted. Positron and neutrino is emitted. Simple as that. Any ambiguities here, beta? This marks the end of this paper. Any ambiguities here, you can ask me right now.